Good morning students, this is your teacher Neela Mehlawat and I hope you are studying well and you are keeping your health very well, right? So today we'll be continuing with the same chapter, that is chapter number 8, motion, and we will talk, this is our third lecture on this topic. So you be very particular and send your attendance to me daily. Don't miss any of the class. Okay, everyone, is it clear? Okay, now keep your books and notebooks ready. We'll start with this. Now yesterday we have spoken about the acceleration concept. So a very quick revision of this, then we'll come to the next concept. So acceleration basically is a change in velocity per unit time. Okay, means how much velocity is changing in how much time, that is called the acceleration. So we can write the formula: acceleration is equal to change in velocity upon time, and mathematically we can say A is equal to V minus U upon T. Mathematically we can say A is equal to V minus U upon T. Okay dear students, and the SI unit is meter per second square. What is the SI unit? Meter per second square. Okay, then acceleration can be of two types. One is called the uniform acceleration, another is called the non-uniform acceleration. Okay, the acceleration can be of two types, uniform acceleration and non-uniform acceleration. Now what do you mean by this? Uniform acceleration means if change in velocity is equal in equal interval of times. Okay, just understand the definition. We'll talk about in next slide about this. Second is non-uniform acceleration. Non-uniform acceleration means if change in velocity is unequal in equal interval of time. Okay, here the change in velocity is equal and here the change in velocity is unequal. Okay dear students, now let's come to the concept in detail. Now tell me, what is U? Yes, what is U? U is initial velocity. And what is V? V is final velocity. Okay dear students, now suppose the initial velocity is 30 meter per second. Okay, what is the initial velocity? It is 30 meter per second and the final velocity is 50 meter per second. Okay, the final velocity is 50 meter per second. Now tell me, what is the change in velocity? How do we calculate change in velocity? We will always subtract this. We will always do this. V minus U. Okay, we will do V minus U. Is it clear? V minus U. Okay, dear students. So what is the change in velocity? The change in velocity is 20 meter per second. Yes, isn't it? Right? Now let's suppose another example I am taking. This is example number 1. Now let's suppose second example. Let's have another pen so that you can see clearly. Okay. Let's suppose now the initial velocity is 15 meter per second. Okay. And the final velocity is 35 meter per second. When I started the car, okay, when I was moving the car was having 15 meter per speed. The speed is 15 meter per second. And now I have increased the speed to 35 meter per second. Now tell me, what is the change in velocity? The change in velocity is again 20 meter per second. So see, the velocity is changing, but the change in velocity is same. Earlier also the change was 20 meter per second and now also the change in velocity is 20 meter per second. So such acceleration is called the uniform acceleration. Okay, such acceleration will be called uniform acceleration. Okay dear students, I hope you've understood. Yes, and now when we plot it, I'm just cleaning it now. Now when we plot a graph against velocity and time, right, you will be taking the time on x-axis and velocity on y-axis. So this will be the graph. The graph will be a straight line. The graph will be a straight line. So what is the graph for a uniform acceleration? The graph is a straight line. Okay, dear students, the graph is a straight line. Okay. Now let's come to the non-uniform acceleration. What we call it as non-uniform acceleration. Let's have now the example I'm taking again. Right? Suppose kariye the first case, the velocity is 20 meters per second and now the velocity is 70 meters per second. So what is the change in velocity? The change in velocity is 50 meters per second, right? Let's have the another case. Suppose the velocity was 30 meters per second and now the velocity is, you can take 40 meters per second. Now what is the change in velocity? The change in velocity is only 10 meters per second. So here you see the change in velocity is more and here the change in velocity is less. So the change in velocity is not same. Okay, the change in velocity is not same when time is same. Means this was also 10 after 10 minutes, this was also after 10 minutes or 10 seconds. So the change in velocity is not same. Then in that case we call this acceleration as non-uniform acceleration. We call this acceleration as non-uniform acceleration. Okay. So, and when we plot a graph for this, the graph will be a curved line. The graph will be a curved line. Okay. So what is the graph for a non-uniform acceleration? It is a curved line. Okay, dear student, it is a curved line. Clear? Let's come to the few more graphs. Achha, before we go for it, we must understand two terms. One is positive acceleration. Positive acceleration. What is positive acceleration? Okay. We know A is equal to V minus U upon T, isn't it? We know this formula that acceleration is equal to V minus U upon T. Now suppose V is 30 meters per second and U is 10 meters per second. So which one is more? V is more. Okay, V is more. So let's put this value. So 30 minus 10 will be, let's suppose time is 10 seconds. Okay, so 10, you will have 20 upon 10. So your acceleration is 2 meter per second square. It is plus, okay, the plus. It is plus. This value 2 meter per second square is a positive value. Okay. So what do you mean by the positive acceleration? Again, let's see. Our velocity, initial velocity was 10 meter per second. Final velocity was 30 meters per second and the time was 10 seconds. So when we put in the formula, the value comes out as plus 2 meter per second square. Isn't it? It is positive. So when we will have positive acceleration? When V is more than U. Okay. When velocity is changing, right? I am repeating. When velocity is changing and the final velocity is more than initial velocity and final velocity is more than initial velocity, in that case, the value of acceleration will be positive. Right? The value of acceleration will be positive. Clear? When the value of acceleration will be positive? When the final velocity is more than initial velocity. Then value will be positive and we call it as positive acceleration. Clear? Next is negative acceleration. Negative acceleration means, see, acceleration formula is V minus U upon T. Okay. I'm taking the value, let's suppose V is 10 meter per second. And U is 30 meter per second and time is again 10 seconds. So just put the values. So you will have 10 minus 30 upon 10. So you will have minus 20 upon 10 and it is equal to minus 2 meter per second square. Here the value of acceleration is minus. So positive acceleration means when the object is traveling, okay, when the object is traveling and its initial velocity is more than final velocity. Which one is more? The initial velocity is more than the final velocity. So we can say u is more than v. Then in that case, the acceleration produced is called negative acceleration. It is called negative acceleration or retardation. It is called negative acceleration or retardation. Clear? Now let's come to the graphs. I know you have heard about the graph paper. You have a paper like this where you find such kind of blocks, isn't it? And where you can easily draw the graph, right? This kind of paper is there and you can draw the graphs, isn't it? So here we will talk about three kinds of graph. One is a distance time graph, and second is displacement time graph, and third is velocity time graph, right? The three kinds of graph we'll be talking about: distance time, velocity time, and displacement time. First is distance time graph. Now in case of distance time graph, we will have distance will be shown on y-axis and time will be shown on x-axis. Okay, that is why we are calling it as distance time graph. So suppose kariye the object is at rest. Rest means the object is not moving. So when the object is not moving and we are plotting a graph, so in that case the graph will be a straight line. You can see here the graph will be a line parallel to the x-axis or the time axis. ठीक है? So object rest पर होती है तो कैसा graph आता है? Like this. Second case, when the object is moving with same speed, uniform speed means same speed. Its speed is not changing. Okay, its speed is not changing. Then in that case, the graph will be like this. We have distance here, time here. It will be a straight line. It will be a straight line. Okay, dear students, it will be a straight line. Now suppose if the body is moving with a non-uniform speed. Non-uniform speed means its speed is changing. Okay, there the speed was same, but its speed is now changing. Either it is increasing or it is decreasing. If the speed is increasing, then we will have this kind of graph, right? Here you have distance, d means your distance, t means your time, and we will plot this, the graph will be like this. So when we have increasing speed, the graph is this one. And if the speed is decreasing, we will have this kind of graph. Now you must understand, see there is a curved graph, isn't it? So this angle we will calculate, this angle. We will calculate this angle. And greater is the angle, greater is the slope and greater is the speed. Okay, अगर ये angle बड़ा है तो हमारी speed भी ज़्यादा है. Clear? Next is your displacement time graph. Okay, so in this case we will have displacement on y-axis and time on x-axis. Now let's see. So if the body is at rest, the body is not moving. So here we have S means your displacement and T means your time. So object is at rest, we will have a line parallel to time axis. Okay, we will have a graph where the line is parallel to time axis. Okay, dear students. Second case, when the object is moving with covering same displacement. So if the displacement is same, we will have this kind of graph. If the velocity is same, if we have same velocity, displacement covered and time taken, so we will have this kind of graph. It is a straight line. It is a straight line. So we have two possibilities. One is this and second is this one. Then comes the velocity time graph. Now in velocity time graph, we will have velocity on y-axis and time on x-axis. Okay. Now if your speed is constant, Suppose the speed was 30 meters per second and still the car is having 30 meter per second. So we will obtain this kind of graph where the graph is parallel to the time axis. So constant speed means the speed is not changing. The speed is same. Okay. The speed is same. So we will have a graph where speed, the graph is parallel to the time axis. Second, you see, if there is the speed is changing but uniformly. Okay, speed is changing but uniformly, or we can say uniform acceleration, because if the speed is changing and the changing is same every time, we call it as uniform acceleration. So graph will be a straight line. The graph will be a straight line. And if it is decreasing uniformly, this is increasing uniformly. And if it is decreasing, the graph will be like this. Clear, students? Now the third case, if the speed is not changing uniformly. Okay, the third case is if the speed is not changing uniformly. So in first case, if it is increasing, so we will have a curved line like this. Okay, and if it is decreasing, we will have this shaped curve. Clear? So here you will have a positive acceleration, but in this case you will have a negative acceleration. Okay, in this case we will have negative acceleration. So I hope you've understood all the graphs. I hope it is clear. Right. So better if you use a graph paper. Use a graph paper and plot a graph on that. Okay, dear students? Let's come to your homework. So you will make notes of this topic and you will go through the page numbers of NCERT, that is 104 to 106. These are very, very important, dear students. Okay, you go through them, underline the main points. If there is any doubt you have, you can talk to me. Okay, I'll clarify the doubts. Clear? Okay. So bye everyone.